Hey there, this is another video for my 40S Pre-Cal students where I'm going to go over a couple of the proofs here from the page 10 of your booklet. It's called Exercise 15. This is from an old exercise book that they used to have us use back before there was a textbook for this course even. And I think 1 to 4 are pretty straightforward. In fact, I think there's a couple in here that were in examples on our notes. I know number 7 is one directly from the examples on our notes. So I'm going to maybe just do, number 5 and then maybe number 8. I think will be the two that we focus on for this video, just to give you a sense of what it's like to do a couple of the tougher ones. And if you haven't tried them yet, I urge you to pause this video before I get into it, give it a try for yourself, and then see the way that I do it. For 1 to 4, most of these are just going to be kind of variations on using the identities here in the boxes. So the ones 5 and 8 have a little more to them than that. So I'm going to start with number 5 here. And always make sure you're copying these right. For number 5, it says 2 secant squared of x is equal to 1 over 1 minus sine x plus 1 over 1 minus, or sorry, 1 plus sine x. See, look at that. I already almost copied it wrong to begin with. So how do I prove that the left-hand side equals the right-hand side? All right, well, left-hand side and right-hand side. Now, you're not really supposed to do these by working both sides at the same time, but it's not a bad idea to just remind yourself what this is. In terms of sine and cosine. Remember, secant is 1 over cosine. So really, this is 2 over cos squared x. So that's kind of what I'm aiming for. With this side, I'm going to manipulate it until I get what I want. All right, well, the first thing I can do is I can add those together. How do you add things together? Well, you add them together with a common denominator. So I'm going to times the top and bottom of this by 1 plus sine x. And I'm going to times the top and bottom of this by 1 minus sine x. And then the common denominator is just the two of them mooshed together. Now, before I go any further, some of you hopefully are starting to see the way that this is panning out already. But before we go any further, I want you to think about the fact that I need the numerator to kind of completely just turn into the number 2. I can kind of already see it, 1 plus 1. And the signs are going to go away. I think I've got the numerator. The denominator, however, needs to be cosine, and there's nothing in it but sines. So start thinking, what identity allows me to turn sines into cosines? And remember, it's this guy right here. Sine squared plus cos squared equals 1. So if I rearrange that, cos squared is 1 minus sine squared, or sine squared is 1 minus cos squared. I can turn cos into sine if there's a square involved using this very handy identity. So I'm going to take this and go, okay, well, those things cancel, and I have 2. And then I'm going to expand that. So first times first. And then this is a difference of squares. So I'm going to get minus sine x plus sine x, which is nothing. So it's going to be minus sine squared x. And oh yeah, this, according to my identity, is cosine of squared of theta. So that's going to be 2 over cos squared, which equals the left-hand side. We're done. So that wasn't all that tough until you realized what it is that you had to kind of work through there. So that was number 5. Let's do number 8 now. Number 8, this guy here, is cosecant squared minus 1. This time it's theta. Over cosecant squared equals cos squared theta. All right, so there's my identity, and I want to prove that that's true for all values that that exists at. And okay, well, obviously I'm just going to leave the right-hand side alone. It's already in cosine. There's not much I can do with it. This side, however, intrigues me. What can I do with this thing? Well, again, a good starting place might be to change everything to sines and cosines, in which case this is 1 over sine squared theta minus 1, and this is 1 over sine squared theta. Well, what else can I do but maybe actually subtract those? And if I'm going to do that, I need a common denominator. So I'm going to times top and bottom of this 1 by sine squared over sine squared, which is 1 minus sine squared theta all over sine squared theta all over 1 over sine squared theta, right? Because this denominator is still right here. All right, what can I do with that? Well, what I'm going to do to make it simpler is, if you have a fraction divided by a fraction, you can change that to times the reciprocal. So the numerator is this fraction, and the denominator is this fraction, and I kind of see where this is going now. Those cancel, and look what I'm left with. I'm left with 1 minus sine squared theta, which, according to that identity, is cos squared theta, which equals the right-hand side. Proven as required. Done. So there we go. For the first assignment, that's about as tough as they get. I'm going to do the lesson for 6.2 on for tomorrow's video. So just keep working through that page and make sure you can do all of these and finish the 6.1 assignment for today. All right. Thanks for watching, everybody.